Hello guys, welcome to codingCastle. Today we are going to solve the Leetcode problem number 3319, kth largest perfect subtree size in binary tree. So in this problem we have to find the size, the number of nodes for a kth largest perfect binary subtree. And now the perfect binary subtree is where the all leaves are on the same level and every parent has a two children. So in the example we can see this perfect subtree binary subtree with the phi as a parent and its leaves on the same level. So to solve this problem, we'll quickly generate the input output first. So the input is root. There we will get the root node for the actual tree, and we have to output the number of nodes for the kth largest perfect subtree. Now I have written some solution steps here. As we have to find all the perfect binary subtrees, we must traverse through the tree first. So for that we can use the DFS. While traversing, we will find the perfect binary tree with this condition where all the leaves are on the same level and every parent has two children. So we'll put the condition there, and once we get a perfect binary tree, we'll quickly save the number of nodes somewhere, and these steps will generate the number of nodes for all the perfect binary subtrees. And once we complete the traversing, we will be having a list of numbers, the number of nodes uh, for all the perfect binary subtrees. Now then simply we can get the kth number as our answer, as it defines the number of nodes for a kth largest binary subtree by sorting the list. So now let's start the coding. First we will write the DFS code to traverse through the tree. So let's pass the root for this function, and click, let's say byte for now, and it will take tree node root, and we'll check the best condition. When we reach the node, when the node is null, we'll return something, and but if it is not a null root, null node, then we'll go to the left side of the tree, and then we'll go to the right side of the tree. That is how we'll traverse through the tree. And so after traversing, we can discuss what we are going to return from this function. So we are going to return a object um, when where the object is containing two fields. The first field will define if the current subtree is a perfect subtree or not, and the second field would be the number of nodes in that particular subtree. So I can send the object for this condition. You can say true, and the number of nodes would be 0. So now I can quickly update here as well. So this is a pair class for the left side of the subtree, and this is for the right side. Alright, so for this pair, I'm not going to write down the class and constructor and all those steps. Instead I can use the record. The record will generate the constructor and getter setter for this field, and I don't have to write anything else regarding this pair object. Now I can directly create the pair object by using this constructor defined by the record. Now after this, our second step is to find the condition for a perfect binary tree. Now condition is, uh, we can say for a particular subtree, I will check if my left subtree is a perfect subtree or not, and then I will check the same for the right side as well. If I find both of the sides are perfect subtree, then I will check the number of nodes on the left side and the right side as well. Those are also are going to be same. If not, because we have to check that all leaves on the same level. So if my left subtree is not having the leaves on the same level as the right side of the subtree, then it is not a perfect binary tree. So that is also I'm going to check. So in the condition I can put the three conditions, like for the left subtree I can check my first field defined here is perfect sub, and this record has generated a getter for this field. So I can use this uh, function or get function to get this value. It will be in boolean. So if it is true, then we can check for the right side as well. And the third condition, I have to check the number of nodes in the left subtree and the right subtree as well. So I can get the count. It is a number of nodes. So let's check for the, so count is a getter method defined by the record. Now it should be equal to the right side number of right side subtree number of nodes. Then if this condition is getting satisfied, then we can say we have found the perfect binary subtree. Now the condition part is done. So whenever we have to save the number of nodes whenever we find this perfect subtree. So before that, before saving, let me return the object as well. So whenever, let's consider this case where the 5 is the parent node and the 1 and 8 as its left and right subtree. So if this is a perfect subtree, I would be passing the true, the object, the true parameter, and the second would be the number of a left subtree plus right subtree, and considering itself as well. So I'll consider the 1 for itself. So this I can return back to its parent. In our case it is a 3 right here. So now if this condition is not getting satisfied, we can simply return the object with the value false, and let's start the count again because it is not a perfect subtree. So now we can follow the third step to save the number of nodes. To save the number of nodes, we will need a list where we can save the number of nodes for every perfect subtree. So it is an answer, and we can say array list, and we can pass this to this DFS function. So I'll quickly update it here in this function as well. And whenever we find it, we can uh, add the number of nodes for the current subtree. That's it. That's it. Then this is the third step we have completed. Now after traversing all these three steps, and after this DFS function, we will get this answer list with some records for the number of nodes for all the perfect subtrees. Then we simply have to find the kth largest. Now to find the kth largest, we can do it by sorting the list in reverse order would be easier. So collection dot sort answer, and let's sort it in reverse order. reverse order, and now we have to just get the kth value as our answer. So let's check the code. Okay, there is some mistake. Okay, so we have some, all right, so we have to update it. Index for the, all right, so this, okay, so we also have to check if the answer dot size is lesser than k, then we are going to, they have suggested here or not. All right, so if the size is lesser than the k, we can simply say -1, or otherwise get the kth value. Okay, it is a zero indexing, so we should say k -1. All right, so this is how we have solved this problem.